I'll be sticking over here since I don't have a clicker with me.
Okay.
Unlike most of the talks I for one, have seen today, this is a very rough sort of walk through a project in a fair amount of detail. It is not polished, and it is also not really practical. A lot of the stuff I had to learn that I'll be trying my best to explain has been very, very useful and could be useful in other projects. But what I did with it is very idiosyncratic and has basically no business justification, which is fortunate because this is barely a business. So
kind of like a lot of those speeches that we've had here in Minibar, not practical.
I was not going to be the one to say it. So I'm James Renken. I'm a sysadmin at IP House, but this is all with one of my side projects, Sandwich.net, a tiny, tiny web hosting company, basically an excuse for me to do things that I couldn't do without a company. What I did is build a global CDN, a content delivery network, to make web pages faster. I have 13 nodes. You may count 11, but there are a couple of locations where they're very close together. And all of these serve content. They're all part of the same small amount of IP space, but it's all global routing. If somebody goes to a particular IP address, it could be served up from any one of these, hopefully, and you'll see why I qualify that, one that's pretty close to the end user. I am a system admin. I am not a network admin. My last encounter before this project with global internet routing ended with me finding out that old Cisco 7200s actually came with a Price is Right failure horn. And I'm also an attorney, so I'm very good at sounding like I know what I'm talking about. When it comes to most of this project, I don't. Some of you probably know better than I do, and please interrupt me and tell me if I'm wrong. There may be a lot of better ways to do what I'm doing better. I hope to find them. Speaking of me being an attorney, no, just no, not legal advice. Also, if any of you have an active security clearance, there is going to be an NSA slide in here, which I understand might be a problem for you. So I'm basically going to go over why I did this at all, what a CDN is, how it works, and how global internet routing works, the very simplified version, and then how the realities of how those things work meant that I couldn't really do things correctly. And then, if there's time, a few specific mistakes I made that were very, very, very hard to identify at first. So, a CDN is a content delivery network. There are a lot of big names that sell this, a lot of small names that sell this. I won't mention any company names while I'm up here of competitors or vendors, but I'll be happy to talk about it afterwards. Ideally, according to Jacob Nielsen, a pretty well-known usability expert, for an end user to perceive a website or application, or an application that is a website, as being instantaneous, for them to have the best experience, the response to anything they do has to be less than 0.1 of a second, 100 milliseconds. Now, if you had a ferret dig a tunnel directly from end user point A to server point B with a fiber optic cable, that could get you about 6,000 miles. That's pretty good, right? Well, now ferrets can actually do wiring. Most ISPs do not work this way. Most ISPs over-provision their networks. They have bad peering with other ISPs. And routers are slow. Servers are slow. You're going to go through a lot of intermediate points that slow things down. So it is not 6,000 miles. It's more like, who knows? Going across the street might be too slow. Going to Texas might be just fine. So it's very unpredictable. A CDN is an attempt to control that, to have not just your users getting to one particular server that you're depending on, but getting to one that's closer to them. Give them the best opportunity to overcome their ISP's faults or just geography and get a good experience. So why am I making my own? Why am I not just buying from one of the smaller names out there? I certainly can't afford the big names. I want to learn how to do this. My last experience with BGP was about a decade ago and ended in tears and failure. But I figured it was time to give it another try. And I like to do things in-house. I'm kind of an old school Unix sysadmin that way. There's also a different reason that I wanted to build my own global network. And that's so that users who are hopefully getting a better experience in terms of performance when seeing content that I host also get better privacy. And I'm talking about mass surveillance. If a user is in, let's say, China, and they get to a node that I have in Hong Kong, then that packet enters a network I control, and I can encrypt it all the way back to my servers here in Minneapolis. So the NSA, unless they have some listening post in China, which they almost certainly do, which is part of why this is impractical, the user has a better chance of avoiding mass surveillance and avoiding security issues and whatever else the internet can throw at them, which is quite a lot. But this might have seemed really, really off the wall about a year ago, last minibar. Then we found out about Turmoil, the NSA's program that taps fiber optic cables globally. A vast, vast number of them. OK, maybe they're only going after terrorists. No, we have this. They are specifically targeting sysadmins, because sysadmins are great people to target to get access to more infrastructure. I don't really care for that. But this isn't paranoia anymore to an unreasonable degree. But maybe it's solving a problem that's my problem. Doesn't really need to be solved. Well, OK, maybe they don't have the best interests of the internet in mind. If they're denying it, but if they knew about the OpenSSL vulnerability for a couple of years, maybe they're up to pretty much everything we suspect they are. So this isn't really paranoia at all anymore. This is just pure security consciousness. And as far as I know, no commercial CDN out there is doing this, protecting user privacy in addition to enhancing performance. Cloudflare may be doing that, but I don't know. And I don't have control over their network. I don't have control over their features. And their enterprise plan that offers some of the features I'd want is more than I can afford, is the same amount per month that I'm spending on my entire infrastructure. So that makes this tempting, if it will work. Maybe it will. So how does the CDN work? You probably know how DNS works. You ask for a name, you get an IP address. And if you have a slightly more advanced DNS setup, one that's pretty common to do, if you're coming from a certain place, you'll get one response from a DNS server. If you're coming from another place, you'll get a different one. Great for splitting up internal and external networks. You can do a lot more with DNS. The Powerdns Geo Plugin lets you do this. There are some others, but that's probably the best documented one. Lets you say, OK, I have a big database file of where different IP space is geographically located. When I get a query from IP space, I'm going to look up where it is, and I'm going to determine which answer I know about is the closest, and I'll return that. So this is one of the fundamental tactics of how a CDN works. All you need is a pretty small change to your DNS server and a bunch more web servers, and you can dramatically reduce latency for your visitors. But there's a lot more you can do, and this is where it gets complicated. With internet routing, pretty much your router tells the rest of the internet, if you're an ISP or a large company running your own routing, hey, I have a route for this IP space. Send requests for that IP space to me. That announcement propagates through other routers on the internet. It doesn't come down to your computer, because your computer doesn't need to know this, but the router you talk to does. With Anycast, all you're doing is having a whole bunch of routers in a whole bunch of places make identical announcements. And instead of bringing a packet into your network at each point and then delivering it to the same place at the end of the chain, they're all the end of the chain. So every single router says, hey, you want to send a packet to this IP address? Sure, I can get it there. And it immediately takes that packet, drops it onto a computer right on its LAN, and responds. So if you're in San Diego, and you make a request to an IP address, you get a response from San Diego. New York, you get a response from New York. Same IP address.
And one of the advantages of this is that you don't have to go to a DNS server that might be anywhere in the world
Right.
for getting it. I did some thesis work on this, and often when there's a long delay getting the web page, it's actually DNS that's at fault, even if you're going to a very nearby replica.
Absolutely. And you can use Anycast for your DNS servers. So you could put your web servers on Anycast, or you could put your DNS servers on Anycast, or both. There are some disadvantages to putting a web server on Anycast, but that's a little beyond our scope here. You can also use, even if you have just a single block of IP space, you can divide it up and announce part of it from a different set of routers, so that basically the only reason to do that, the reason I'm doing it, is if you know you are going to break your own BGP configuration at least 4 times a day, you still have one server that's working. This is a little bit impolite to the rest of the internet because it takes incrementally more memory in everybody's router to store that additional route. But until I know what I'm doing, it's a little safer for me. You could take this a little further. There are all sorts of ways you can combine these options. You could write custom DNS server software that actually looks into the routing table rather than just thinking it knows where IP addresses are. As far as I can tell, there's no open source software that does that. But this is what a lot of the big names in the CDN industry are doing. So I've mentioned internet routing. I've mentioned Anycast routing by having routers in multiple places, all responding and all taking traffic that goes to basically themselves rather than back to Minneapolis, let's say. The protocol routers speak to each other to say, hey, I know how to reach this IP space, is called BGP, the Border Gateway Protocol. It is very, very complicated. It's very elegant, and it's really scary. Because even though it's designed to be really reliable, you can lose links, links can get overloaded, all sorts of things can go wrong. But if you configure it wrong, you are doomed. Weird things will happen, and you will not understand why unless you're an advanced network admin. And this is what bit me a decade ago when I last tried to play with this. And it's bit me many, many times over the past few months. And there's no one out there to help. With a server, with developing software, you can go on Server Fault, Stack Overflow. You can maybe call up a vendor. You can talk to colleagues. You can even just go on Google. Someone has probably encountered the same problem, and there are a limited number of ways you can describe the problem. Very few people know BGP, especially when you're trying to do something advanced. Those people are all working for large, large ISPs who don't want to talk about how they build their internal network. So you really are going to need a mentor to do this. I am very fortunate to have patient and understanding coworkers. So when you're working with a router that has BGP enabled, it understands where things live on the internet. It handles traffic that you send it by saying, OK, I have this big list of different ways I can reach different IP addresses. What are the ways I could reach this IP address? OK, what is the best way I can reach this IP address? But the way BGP is designed, all best means is shortest. But that's not necessarily good. Shortest doesn't mean shortest. Shortest means the fewest number of intermediate ISPs to go through. And if you have a direct path through an ISP that's massively overloaded, but just not quite enough to break, that path is going to be preferred over a couple of hops through much better ISPs, or much closer ISPs geographically speaking. So BGP distance is not low latency distance, and it's not geographical distance. And this can really bite you when you're trying to design a high performance network. When you're building a CDN with a whole bunch of nodes, what can happen is called tromboning. If you have different ISPs in different places, somebody in New York sending you a packet, when you have a presence in New York, may end up going to California because that's where their particular ISP thinks they have a best path to you. So if you don't have the same ISPs everywhere, this may happen. There are some ways around it, and some of the weirder stuff I ran into is trying to make those work. It's very easy to say, use the same ISPs in all the places you are. But if you're trying to build a global network, there aren't many to choose from. And if you're building a global network on a very small budget, the ones that there are to choose from aren't the primary providers. They work with larger global providers, and they all work with different ones and different sets of them. So you need to do a lot of research. If I'm going to start a node in Australia, am I suddenly going to see people in London going to Australia instead of going to Zurich? This actually happened. It wouldn't be so bad if I had one site here in Minneapolis and everyone had to go there. It wouldn't be great, but it's pretty much the status quo for a basic web server. But as I'm trying to make performance better by having nodes all over the globe, suddenly I'm sending people across 2 oceans. That's no good. But there are ways to get around this. The problem is, this starts getting to be a big hack. You're working with things that are changing constantly. You're working with business relationships that are changing constantly and aren't always visible to you. And you're working with providers that may not provide you the information that you need to make good decisions about how to manipulate your routes. So one way you can do this in a situation like mine, where you're working with lots of small ISPs, you have no direct connections to global carriers, is you can look at the data attached to routes and say, OK, this route is coming in from Europe, but I'm a node in Australia. I don't even want to think about using this route, so I am going to ignore it. I'm not even going to add it to my routing table. I am going to try to send outbound traffic only to routes that I know are at least on my continent. If it's not on my continent, I'm going to prefer another route. And hopefully, somebody else in my own autonomous system, my own sphere of influence, will know how to get there more efficiently than I can. Controlling incoming traffic is practically impossible, though. You can manipulate outgoing traffic if you go to a really enormous degree of research and trouble. You can go through the entire routing table by hand and say, OK, this is the best way to get here. This is the best way to get here. But with incoming traffic, you are not making the decisions, and you have minimal control over the people who are. So you can tell ISPs, I have a way to get to this IP address. That's basically all you can do. The only way you have to manipulate incoming traffic is by deciding whether to tell an ISP that you have that route. So if you're in Australia and you're connecting to 2 or 3 different ISPs, one of them has a lot of global connectivity that's really, really pretty much a single provider. They're a big provider. They have direct customers in Europe. You can look and say, OK, I am not even going to bother sending them my route, telling them that I'm a good way to get to this network, because I know that they will be bringing me traffic from the wrong place. For outgoing traffic, you're in the other position. You can look at the data that they're sending you and say, OK, I see where this route came from. I know what I need to do. I know how to best route this packet to avoid going to the wrong continent. There are a lot of other ways to engineer traffic that I simply don't understand. Many of them are patented, and I have considered, but thought better of, reading the patents and then figuring out how to do what they're doing and try not to get sued. But I really would not recommend that. That's some legal advice I feel comfortable giving. Don't do that. But now let's get more impractical, because it was not impractical enough. Let's say that protecting visitors' privacy is an even higher priority than high performance. We know that these ISPs have been collaborating with mass surveillance by governments. We're not sure about Sprint, but it's very probable. You can configure your router to avoid, where possible, and it's not always possible, any route that goes over these providers. Unfortunately, these are all the best and largest providers. So let's not use the freeway. Let's take the dirt road instead because it's safer, is basically what I'm saying. This is hilariously impractical. But if I were hosting websites for, let's say, activist groups that really upset governments that are even less friendly than ours, I would definitely consider doing this. If I were working with a lot of content for distance in the Middle East, if there's a way to avoid intelligence partners, even if it's going to increase ping times by 200 milliseconds, I'm going to do it. So backing away from internet routing, which I can barely explain and barely understand, and back to some more basics. Normally, BGP routers are big, expensive, multiple $1,000 rack mount gear that come with support contracts and come with solution engineers in bad ties who want to come and waste entire afternoons asking what your budget is so that they can increase the zeros on the end of the price tag. You don't have to do this unless you're running a very high performance network by my standards. That is to say, anything above about 500 megabits, which is not really that big. But if you're a tiny side project, that is more than enough. The Quagga software router has most of the features of a major brand hardware router, and it is free. It uses pretty much the same configuration language. It can speak with pretty much any other kind of router, unless you want to use proprietary routing features. And it doesn't need many resources. You can put it on a cheap VPS. That is exactly what I did. That is how I have 13 nodes for $20 a day. That is literally about what I am paying. You need about 1.5 gig of RAM for each one because routing tables are huge. Most of my nodes have about 400,000 and change routes. But which cheap VPS providers? If you read Hacker News, you will think of two names and only two names. They do not do it. You need to find small providers where you can get directly to technical people. And you need ones with good connectivity and the right connectivity. If you get one provider where the connectivity is too good, you'll find yourself attracting traffic there from the wrong continents. So we're back to the really, really impractical problem of not having enough money to work directly with global carriers. You need a full routing table. A few providers that I've encountered will say, OK, well, I guess we can speak BGP with you. We can give you a default route and maybe a few thousand routes. But the rest of the internet, just send it to our router and we'll worry about it, which is fine if you're not trying to do traffic engineering. It's not fine if you are. Communities are a nice thing to have. Some providers don't pass through routing information that they receive from their carriers. They just take it out and simplify things and maybe substitute their own. That's not required, but it's a really nice feature to have. If you can find someone who will keep communities, that's great. There's one large, well-priced global backbone that is known for quality network engineering that doesn't support communities at all. I don't really know why. Now, back to impractical. If you're trying to pick which cheap VPS providers to use, and you really care about privacy, where are you going to go? The approach I took, which is probably flawed because the NSA is smarter than I am, is to have a bunch of nodes, obviously in the US, where I have the vast majority of visitors, where I need the best performance, but also in other countries that are surveillance partners with the US, because we know the NSA theoretically can't spy on American citizens. Now, they do anyway, but they just argue it's not actually spying. But when they really want to spy on someone, they just tell one of their partner countries, hey, can you spy on our citizen for us? And they do it. I'm not making this up. So ideally, you want to have a node in other major countries that are partners with us so that people in those countries have a little more protection from us spying on them. And then you want nodes outside of our partner countries so that people who are in those countries or are in that region can avoid mass surveillance entirely. Or not, because the NSA is smarter than I am, but I digress. We know that these countries are US partners to varying degrees. The closest cooperators are at the top, going down. We don't know about Japan. They're pretty fiercely independent in terms of personal freedom for their citizens, but we do have a major signals intelligence base there, so 50-50. I put most of my cryptographic infrastructure, my most security sensitive stuff, in Iceland. They're very independent, they have an excellent record, and they don't have a mutual legal assistance treaty with us. That means that if our law enforcement sends them a formal request to do wiretapping, it's not going to be super easy to get that done. Finland is another such country that's very independent, doesn't have a treaty with us of that kind. I believe Switzerland does, but they have a long history of being independent. But because of financial crimes, they're collaborating with us a lot more than they used to. I wouldn't count on it. We know Hong Kong isn't collaborating with us, but do you want to be spied on by the Chinese? Maybe that's better. Hong Kong's great. A lot of Asian countries are either not friendly places to do business as a US citizen, or are known to be wiretap friendly as far as the US goes, or simply have terrible connectivity. I think Hong Kong is probably the place I want to have a node in East Asia when I can afford it, but it's also very expensive to do business there. We'll see how that goes. In Asia, there aren't a lot of really great choices in terms of avoiding all surveillance and having decent connectivity and not paying enormous amounts of money. But speaking of paying enormous amounts of money, here's why I do not have a point of presence in Finland. I'd really like to work with them. They have a long history of innovating with internet services. Linus Torvalds is from there. IRC was invented there. They're very independent. They have great respect for personal freedom. But they really don't make it easy for foreigners to do business there. I don't have a problem with that. I kind of appreciate that. I'm much more of an engineer than a business development type. But I'd really like to at least be able to buy a server there, and I can't. Because this is what I would have to do to form a subsidiary there, which the one ISP willing to even talk to me would require in order for me to buy their services. That's quite expensive. I was going to do all of this. Then I found out that the monthly price that they would charge on top of these setup fees would be more than I'm paying for literally everything else. If you know anyone in Finland, I would love to talk to you. So, we've got the points of presence. We've got the routing. We've probably broken the routing a few times. Maybe we've fixed it. There's one thing you need in order to do any routing at all, and that's IP space. As you may know, we're running very, very short on IP space. There are only so many IP addresses. Most of them are allocated. The world is in the process of moving to IP version 6, which has exponentially more IP addresses. That hasn't happened yet, and it won't be good enough to just have IPv6 for probably 20 years from now, I'm guessing. So you need IP space, and they don't make it easy. The rules are different if you're an end user. If you're a company just setting up your own infrastructure to communicate with your own clients, the rules are different. They're much simpler. They're just about as expensive, but they're much less restrictive. But if you're an ISP, in order to get IP space, you need to have IP space. That's great, isn't it? You can get IP space from the ISPs that you're paying, but they will probably charge 6 to 8 times what they're being charged by the registry for the IP space, because there's a lot of overhead in managing this stuff. And also, money is nice, isn't it? You also can't really go outside of our region to other regions where it's easier to get IP space. They ask you where you're going to be primarily routing it from. And everyone outside of ARIN, the American Registry for Internet Numbers, charges much, much more. Don't bother. So I went through about 3 different times the process of applying for IP space. And I finally got to the point where I had enough space for my providers and enough customers using it that I could honestly say, without lying, that I am efficiently using IP space. And they do things on a ticket system. They ask you for one thing, you respond. They ask you for another thing, you respond, etc. Each cycle takes about 48 hours. So if you know what they're going to ask, just give them an info dump, and you'll have your IP space a lot quicker. Here's some of what they ask for. Here's more of what they ask for. And going back to that one, yeah, they ask for customer names. And if you have it in your privacy policy that you're not going to disclose customer information, you have a problem. You need to take a few months to amend your privacy policy and notify your customers, and don't do that. Write it into your policy right away. Or have some very cooperative customers. Do all of this, and you'll get your IP space. Why go through all these steps? So you don't have to pay that 6 to 8 time markup. $500 a year is not a lot in the grand scheme of things, even for a pretty tiny project like mine. And you have your own IP space. If you switch ISPs, if you have problems, you can move, you don't have to renumber. You can make things very, very seamless in the future. It is great having your own IP space. Also, if you have an ISP that's very, very annoyed by even the tiniest little spam complaint from somebody who's annoyed that their grandmother sent them a chain email. I work at an ISP that does a lot of email. This happens all the time. Those now go to you and not to that very nervous ISP. But if you're planning to use the fact that you have your own IP space to avoid spam complaints for a different reason, I will find you. I have already taken an interest in finding spammers who get interesting IP space under interesting company names in interesting parts of the world, and notifying all of their upstream providers, and notifying all the blacklists. I will find you. So once you've gone through all of this hassle, you have your own global infrastructure, you need to do it right, because once you're running a BGP router, if you go and delete Internet Explorer, you have not broken the internet. If you mess up your BGP configuration badly enough, you have broken the internet. Congratulations. This has actually happened multiple times. One of them very recently. I believe the company in question was Indosat. If your upstream providers will accept any announcement from you, if you say, hey, yeah, I can accept traffic from Google, send that all to me, I'll route it onwards. If they're not smart enough to not do that, congratulations, all of Google's traffic is now coming to you. Good luck with that. People will be very upset with you, and they will have very good reason to be upset with you. Don't do that. As I mentioned, find someone who can tell you what you're doing wrong. Look up BCP 38 so that your customers can't send traffic that's forged and facilitate DDoS attacks and all sorts of other nasty things. Have an abuse address, answer it. And there's some useful resources you should sign up for. BGPmon will email you if somebody else starts announcing your IP space. That's very handy. If somebody makes a mistake and announces more IP space than they should, you'll find out and you'll be able to call them. How will you call them? puck.nether.net has a big phone list of BGP operators' phone numbers that will usually get you directly to them. And INOC-DBA is the coolest thing. It is a free VoIP interchange where you pick up the phone, you dial an AS number, and you are connected directly to a network operator. It is fantastic. Don't abuse that, though. People will not be happy with you, especially at 3 in the morning.
That only works, though, if your web connection is not going through your BGP route. It's like you just wrote.
Good point. SIP is particularly sensitive to that kind of stuff too.
So do your point of presence charge you extra for access to advertised BGP routes? Or just
They do. The ones that I am lucky enough to have found, not through just a little effort, but a lot, a couple of them charge me $20 a month extra. That's not bad.
that's not bad at all, no.
Some want to charge me €300 a month extra, and that is a problem. But I found a pretty good set who give me a pretty good balance of global ISPs for not much money, $20 a day. Subscribe to the North American Network Operators Group mailing list, but get the digests. It is very high traffic. You don't have to read it, but just search for your own name, your own IP space, and your own AS number now and again. See if you're messing up and people are talking about you. People will get very upset if you are completely oblivious. So what I have, putting this all together, is my attempt to avoid the NSA's turmoil program tapping fiber optic cables. I call it turducken. And I have all of my nodes talking to each other over IPsec. I'm running GRE tunnels on top of that. And I'm running BGP on top of all of that, and then routing packets through the GRE tunnels, which are encrypted by IPsec. So a user in Australia wants to talk to an IP address I have. They're routed to my Australian node, which immediately encrypts the traffic, then sends it on to, let's say, Minneapolis. And on the way back, Minneapolis sends it on to Australia encrypted. It's only decrypted for that last couple of hops to the visitor. This is what I did. I found all these providers. I set up cheap VPSs. I set up IPsec, which is very hard. I recommend using StrongSwan. A lot of the guides out there recommend using Kame, but they are not updated. And StrongSwan has copious documentation. GRE tunnels are pretty simple. BGP is not simple, but I'll be happy to share sample configurations. And then you want a web server. I think that's what that thing is called. And good luck selling this, because this is not a high-performance network. I've made a lot of compromises in terms of doing things securely, and a lot more for doing things cheaply. This is really not a high-performance CDN, but it's fun. So I have a little time. What have I done wrong along the way? Well, if you have a tunnel to another node, and you're running BGP over that tunnel, and you learn over BGP what the best route to that node is, you knock out the route that your BGP session's running on. That's great. Everything dies. Not immediately, after about maybe 3 minutes. Then it stops working and the session resets and you don't know why. That was why. There are some tricks you can use with Linux advanced IP routing to work around that, or even more basic stuff. It works pretty well. Don't use pre-shared keys for IPsec when you have 13 nodes. Oops, I accidentally got a duplicate SSH host key with some other customer because my VPS provider here sucks. Timed update, oh good, 13 configuration files. Fantastic, don't do that. Use certificates, they're hard, but they're worth it. And I had an ISP, and this happens especially with VPSs because cheap VPSs are attractive to people who might want to abuse them. A lot of ISPs filter the outgoing traffic from their VPS networks so that only the IPs that should be sending traffic out can send traffic out. Well, I brought my own IPs, and I got everything set up, and it kind of looked like it worked. But I was just unable to reach some destinations, and I couldn't figure out why. Well, connectivity from that node seemed to work, but outgoing packets from my actual IP space were getting filtered, but only when they went out that provider. So look for that. That will break things. And that's it. I am happy to accept criticism, recommendations, questions, heckles.
So do you anycast your whole IP assignment or a smaller block of it?
Much smaller block. I have a 22. I use 24 out of that for my backup. Oh great, I just broke my main BGP configuration. And I only anycast about I think a 25. And then I think like a 26 out of the backup as well. So I have a lot of things that are really operating like a traditional routed network. They come into my routers in various places, and they are brought back to, let's say, Minneapolis. But then that little piece of the network, which is where my content delivery stuff lives, that's where each node responds individually. So it's partial Anycast and partial just a traditional large network.
Are there any like conventions around advertising small routes? Like, so you don't pollute everyone's router tables with single hosts or things like that?
Glad you asked. The convention is announce as few routes as possible. I'm being mildly impolite by breaking out one route as a backup. Probably not too bad. But to prevent extreme impoliteness, pretty much a good portion of large ISPs will not propagate routes for anything smaller than a 24. That's 256 IPs, 1.2.3. anything. If you try to announce anything smaller than that in the global routing table, you will not have reachability from everywhere. So that's something that ISPs use a lot to prevent pollution of the routing table. And that's why you need to get your own IP space, or at least get a big amount of IP space, rather than just getting whatever maybe 16 IPs your ISP gives you, because you won't be able to route that.
And if you annoy somebody, they will just put a filter in that says, I'm not carrying that ASN anymore.
Yeah, another good reason not to annoy people. Anyone else?
How much of a performance did you see from this?
Most of my nodes only have 100 megabit uplink, and I've been able to get 98. It's not bad. I've heard that Quagga, the software router I'm using, really starts falling down around 700 or 800 megabits. So if you're running a real production CDN, either you need a lot of little independent networks, or you need to do things right and buy actual hardware routers. The hardware for which is probably backdoored by NSA, so good luck.
How old is that version of Quagga?
It's pretty well maintained. It's not a fast-moving project, but it's getting updates. I think the last stable release was not more than a year ago. It's relatively recent.
Yeah, I've used it quite a bit in the past. It was 700 megabits. That's kind of low. I was able to push from the gig through it. But
Nice. It's probably the fact that I'm running on cheap VPSs. And I haven't really fully tested it out myself because I don't have the uplinks with which to really test it.
Sure.
But I would love to do that in a lab environment and see how far I can push it. I don't think I'll be able to max out 10 gig E though.
Yeah, I haven't seen like a big hit on the CPU in anything above 2 or 3 gig, but I don't know.
That's really nice to hear.
So it does scale.
So is there any way we can actually deploy IPv6 when everybody and their dog will have enough address ranges to do this? I mean, the limit on the routers is not memory. It's the, how many TCAM entries are in the forwarding ASIC. Right?
Mm-hmm.
Sorry, I started. I don't know how to.
You're talking real routers again.
Yeah, and that's what actually limits it. So, is.
I've got
What?
IPv6 on my phone.
Yeah.
With T-Mobile, like, it works.
I
So they just have to get it, Comcast, everybody.
yeah,
does it.
but
The
less
routes
than.
are you're going to have, like, you can't do routes, or you can't do announcements for anything smaller than /24. You're going to have to start looking at your routing tables being gigabyte range. If you start including, if you include large, smaller IPv6 blocks.
But I guess, what am I trying to say here? It seems like the amount that you will need to charge, either you will have, about the same number of bits today in terms of what can go in the global routing table, or you're going to have to charge a heck of a lot more to inject things into it.
Probably going to just have to,
And
scale it up, but it's going to be an exponential growth of your routing table if you start looking at it like that.
But I mean, we're already exponentially growing, and 2% of the backbone traffic is
Yeah.
IPv6. That's how much adoption there is. So
Yeah, you're going to be looking at the routing table for something like this project, especially if you're going to be doing anycast. You're going to be looking at local routing tables probably growing about 25 times at least.
It's a pity Moore's Law has slowed down.
Any idea how, so what, they won't announce, a lot of providers won't announce smaller than a /24 or
Mhm.
IPv4. What's the IPv6 space that, the smallest IPv6 space they'll announce?
There was a discussion about that on Nanog, and there's no firm conclusion that I saw. Maybe I'm wrong. I think people were saying about a 48, but that I got the impression that's very much up in the air.
I think those sorts of conventions will have to be developed as IPv6 adoption increases, just like the conventions developed under IPv4. I mean, that's just what they agreed to, it wasn't hard written.
It's up to any individual provider to
Right.
figure out what they're going to carry.
At one point, there was some discussion about IPv6 and having the routes being set up such that they could try to geographically consolidate them and filter them. Seems like, I guess I haven't followed that.
That's the
but seems like in the
But
past-
that only works as long as you don't want a multi-home.
Yeah.
Right?
Yeah.
And one of the benefits of having your own IP address is so that you can
Yeah, I think that's why
multi-home.
it hasn't really gone that way. I wouldn't be surprised though, the whole routing table is gonna grow a lot, but the routing algorithms, when they put it into which routes go, which interfaces, do a lot more optimization than they maybe do now.
There's
There's
going to be more
updates.
aggregation.
Yeah, it'll aggregate when it flows into the CAN cables.
Yeah.
With,
But,
there's already
yeah,
massive updates.
that's what I've been seeing and Nana talking about when they've been talking about IPv6, and actually for IPv4 table, routing table, optimization is aggregating, rather than just next hop, as well as next point, they've been talking about actually further hops.
And that's really irritating if you're trying to do fine traffic engineering, if you don't have a really accurate view of what it is that your possible paths are.
What other routing protocols did you look at when you were talking about this?
I looked at doing simpler routing protocols or different routing protocols internally, but the problem is every one of my routers is an edge router. I didn't try to do this, but I am informed by plausible sources that if you try to push 400,000 routes into OSPF, it will fall over wonderfully.
Wonderful.
Is
Is this wonderfully, James, in the pejorative sense?
You might say that.
Like, Berkeley was wonderful.
Oh, yes. As,
fail in an interesting way, that's what.
and I would really like to use a different routing protocol internally because the way BGP path selection works makes it kind of difficult to do some of the traffic engineering techniques I'd like. But I haven't found an internal routing protocol that's actually suitable for this kind of load and suitable for what I want to do that I can even vaguely understand. And that's implemented in open source software, for that matter. Yep.
There you go. Cisco, it's open-ish.
All right, we are out of time. Thank you very much.
Southor.
I thought a lot of the weirdness with BGP was actually that they didn't do actually shortest path. They applied all sorts of weirdo business logic in terms of, I want to send traffic to this AN over, level 3 because I hate them, or
They're
Yeah.
practical and theoretical.
A lot of backbones are doing sort of what I described in terms of punitive traffic engineering for business reasons. Like, I want to keep things in my network as long as possible, or for as brief a time as possible, more often. I want to send things through customers if I can, because I get money for that, versus peers where, I'm not paying for it, but I don't get money for it. I definitely don't want to send things to places where I have to pay to transmit it. So those business decisions implemented in routing by large ISPs also affect how much I'm able to engineer my traffic.
Yeah. And that actually was recently that our backup connection wasn't as reliable as we thought because the primary ISP started flapping. At our secondary IP, actually, we had set to prefer going to our primary, but its announcements to the secondary ISP so don't announce to these other ones, which when they start getting filtered due to other reasons over here, you know, several of these routes dropped out, and we didn't have global connectivity anymore, and we had to then react and switch and change that.
Sorry, I didn't prolong the
No worries. End of the day. Thanks for coming, everyone.